All right, welcome to class, everybody. I hope you guys are having a good Monday so far. So on your tests, I just picked them up from the testing center today, and I should get them all graded tomorrow. So I'll bring them with me on Wednesday. And our section for today is section 5.3, which is about dividing polynomials. So we've talked with adding and subtracting and multiplying, how you can view polynomials kind of like as place values. And that way of looking at polynomials is going to be really, really helpful today. So to start off our discussion, I want to talk about when you can distribute division and when you can't. So if you have something like this, where you have 6 plus 4 divided by 2, you could just simplify the top of the fraction and get 10 divided by 2, which equals 5. But another way you could also do it is you could distribute the division by 2 to both of the terms. And you could say 6 divided by 2 is 3, 4 divided by 2 is 2, and 3 plus 2 still gives you that answer of 5. So whenever you're dividing by a single number or a single term, you can distribute that division just like you would distribute multiplication. Now you can't do that in the opposite direction. So if you have something divided by 2 terms, you can't distribute this to both of these terms. Because if we were to simplify this just by doing simplifying the bottom, 2 plus 1 is 3, and 9 divided by 3 equals 3. But if you were to distribute, which you can't do, so I'm going to do this in red. If you did 9 divided by 2 and added that to 9 divided by 1, this would be the same thing as 4.5 plus 9, which is definitely not equal to 3. So this kind of illustrates the fact that if you have division by 2 things, you can't distribute it like that. You can only distribute it with a single term. And that's important when we're dividing polynomials, because if you have a polynomial division problem like this one, where you're dividing by a monomial, so a single term, then you can just distribute this division to each term. So you could say, okay, well, 10x to the 5th divided by 5x squared minus 15x to the 4th over 5x squared plus 20x cubed over 5x squared. So essentially, I'm distributing this division to each term. And if I have 10 divided by 5, that's going to equal 2. And x to the 5th divided by x squared is going to equal x cubed. The reason for that is because if I have 5 x's multiplied together over 3 x's, or 2 x's actually, so 5x to the 5th divided by x squared, x divided by x equals 1, and they cancel out, and you're left with 3 x's that didn't cancel out. Is everybody good with that? On how I simplified this to get this? And you don't even have to write this out. Like if you want to do it in your head and say, oh, 10 divided by 5 is 2. X to the 5th divided by x squared is x cubed. You can totally do that. So if I do the next term, negative 15 divided by 5 is going to be negative 3. And what would x to the 4th divided by x squared be? Yep, nice job, x squared. And then 20 divided by 5 is 4. And x cubed divided by x squared would be x, just a single x. Now, sometimes you might get a term, this wasn't in this problem, but if you had something like 30x over 5x squared, if you have something like that, then you would write this as 6 over x. Because in that case, you have a single x over 2 x's, which means that the x that didn't cancel out is in the denominator. So sometimes you might end up with stuff like that. Okay, any questions about that or how to divide by monomials? Yeah. Yes, you could also write that as like that, and that would work too. Yeah, and you might notice that there's a consistent pattern where you just subtract the exponent. So like 3 minus 2 gave you an exponent of 1, or like 5 minus 2 gives you an exponent of 3. And so you could do that here too, where you do 1 minus 2 gives you a negative 1. And we'll talk more about negative exponents when we get to our exponent unit, but that would totally work. Yeah. Any other questions on this one? Okay. On question 4 on your homework, they have some where you have A's and B's, but the process is still the same. So like you'd say 35 divided by 7 is 5, A cubed divided by A squared is A, B to the 5th divided by B squared would be B to the 3rd. And you would do that same process even if you have multiple variables. So that's the easy way, or I guess problems like this are easy to do because you just distribute the division. But you'll also be asked to solve problems like this, where you're taking a polynomial and you're dividing by multiple terms. And as we saw on that first slide, you can't just distribute it to each term individually because this can't be simplified in that way. So when you have a problem like this, where you're dividing by a binomial or a trinomial or something that has more than one term, then you need to use a polynomial version of long division. So is there anyone who would like a quick refresher on regular long division before I show you the polynomial version of it? Okay. Are you guys sure? Because most of the time when I teach this lesson, like people are like, yes, I learned long division in 5th grade and I forgot. So are you guys okay if I give you a quick little review for that? Okay. So let's say that we had something like 1,000 and I don't know, let's do 53 divided by 2. Okay, so ultimately our goal is to take this number and divide by 2. So this is long division that we learned in 5th grade. But at least in my experience, most people don't understand why the process actually works. So to show a picture version of why this works, let's take 1,000, 5 tens, and 3 ones. And our goal is to split this number up into 2 groups. So the way long division works is you start with your largest place value and you say, if I have 1,000, can I split it up into 2 groups? Or can I divide it? We can't, so we put a 0 there. And then you move on to your next place value and you say, well, I have 0 hundreds, but this 1,000 can also be broken up into hundreds. So I have 10 hundreds. And you split those 10 hundreds up into 2 groups. So I'll just kind of split them up there. And in each group, when I do those 10 hundreds and divide them into 2 groups, I end up with 5 hundreds in each group. Then you do 5 times 2, which gives you 10. And that number is describing how many hundreds you used up. And so you subtract that from the number that you still need to divide. And so you have 0 hundreds left over, and then you bring down your tens and you start on your tens place. And you say, well, if I have 5 tens, if I divide those up into 2 groups, I can put 2 in each of my groups. So I put a 2 in my answer. Then I do 2 times 2 is 4. And I subtract those 4 that I divided up, which tells me that I have 1 10 that still needs to be divided. Then you bring down your next place value and you have 13 ones. So I can convert this leftover 10 into 10 ones. And when I divide those 10 ones, as well as my other 3 ones into 2 groups, I end up with 6 ones. And 6 times 2 is 12. And when I subtract that, I have a remainder of 1. Now you can just write the remainder as 1, but you could also take this 1 block and cut it into 2 pieces, which means your remainder could be written as 1 over 2. Is everybody good with that? So this is just a review of regular long division. And with polynomials, we're going to go through the same process, except instead of having a thousands and a hundreds and tens and so on, we're going to have x cubed, x squared, x and constants. So let's go back to the problem we have here. So in this problem, I'm going to write out the number or the polynomial that I'm dividing. So I have 4y cubed. And in this polynomial, we don't have a y squared, but for the purpose of long division, it will be helpful to have a spot reserved for the y squareds. So I'm going to write plus 0 y squared to give me some space for that, because adding 0 doesn't really do anything. And that's just going to give me that place value. Then I'll have negative 6y minus 11. Is everybody good with where this came from? Okay, then I'll divide this by 2y minus 4. And so remember, long division kind of has like 3 steps that you go through over and over and over. So if we go back to this number version, we did 10 divided by 2 gave us 5. Then we did 5 times 2 gave us 10, and then we subtracted. So you divide, multiply, subtract over and over and over with each place value. So when we go to the division step, you only look at the terms with the largest degree. So I'm going to do 4y cubed and divide by 2y. And I'm not going to pay attention to this stuff with lower degrees for right now. So I say, okay, well, 4y cubed divided by 2y, 4 divided by 2 is 2, and y cubed divided by y is what? Y squared. So this is what goes in my answer. Then I take this and I multiply by this, and I multiply it by the whole thing. So I do 2y squared times 2y gives me 4y cubed, and 2y squared times -4 gives me -8y squared. And this is why it was helpful to put a 0 y squared in here, because it gives me a column to put my y squareds in. Everybody good with that? So I multiply, and then my next step is to subtract. And when you subtract, you have to make sure you subtract the entire thing, which makes this +4 negative and the -8 positive. So make sure that you subtract both parts, or if you have 3 parts, that you subtract all of them. And when I subtract that stuff, the y cubes cancel out, which they should do, because that was kind of the whole point of dividing it. And then 0y squared plus 8y squared leaves me with 8y squared minus 6y minus 11. So that was my first round of long division. Now I'm going to keep on doing this until everything is divided. So I say, okay, well, my next place value is the y squareds. 8y squared divided by 2y is 8 divided by 2 equals +4. And y squared divided by y equals y. Again, I'm only dividing the largest place value when I do the division step. Then I multiply and I say +4y times 2y minus 4 is 8y squared minus 16y. Then I need to subtract that. So I make the positives negative and the negatives positive when I subtract that. And what I'm left with is 10y minus 11. Then I go through the process again and I say, okay, well, 10y divided by 2y would be what? Yep, just plain 5, +5. And then +5 times 2y minus 4 would give me 10y minus 20. Then when I subtract it, the 10y becomes negative, the 20 becomes positive, and that leaves me with a remainder of 9. And the reason this is my remainder is because the degree of what's left over is smaller than the degree of what I'm dividing by. So this is my remainder, and I'm going to write my remainder as +9 over 2y minus 4. So kind of like when we did with the whole numbers, where we had a remainder of 1 and we wrote it as 1 divided by 2, because I took that one remaining block and cut it into 2 pieces. And I wrote my remainder like that. It's basically the same idea here, except my remainder is 9, and the thing I was dividing by was 2y minus 4. And so this would be my answer. And you can use this method to divide problems like this if you wanted to, but I think it's easier to distribute the division, so that's why I showed you this first. But you could use long division on this as well. And essentially this term right here, if we had had that blue term, this would have been the remainder. And that's kind of where that would have shown up. So any questions on this process? Okay. So one of the places that I usually see people make the most mistakes, and this is also where I make the most mistakes, is in these subtraction steps. So it's relatively easy to do the multiplication and the division and all that, but make sure when you do the subtraction that you subtract all of the terms. Because the mistake that I see a lot is that people will subtract this term, but they'll forget to subtract this one. And if you did that, that would have made this a -8y squared, which then changes all of your results from there on out. So make sure when you do the subtraction step for long division that you subtract everything and change those signs. Okay, would it be helpful if I do one more example? To kind of show that process again. Okay, so this one, we have a larger polynomial dividing this time. So we have 3a cubed minus 11a squared plus 5a plus 10. And we're dividing this by 3a squared minus 5a minus 5. So I'm going to start with my largest degree terms. And if I do 3a cubed divided by 3a squared, what does that end up equaling? I think I heard someone say it. Say it again. Yep, it would just be 1a because 3 divided by 3 is 1. A cubed divided by a squared is a. So that gives me a, and then I need to multiply a by everything that I'm dividing by. And so that gives me 3a cubed minus 5a squared minus 5a. And then when I subtract it, the 3 becomes negative, the 5 becomes positive, and the other 5 also becomes positive. When I combine those together, this term cancels out, and I end up with negative 6a squared plus 10a. And then I move on to my next, oh, and sorry, I should actually write this plus 10 there as well. And then I move on to my next place value. I say if I have negative 6a squared divided by 3a squared, what does that equal? Yep, negative 2, because negative 6 divided by 3 is negative 2. A squared divided by a squared, both of the a's cancel out. And so you just get negative 2. And when I multiply that, I get negative 6a squared plus 10a plus 10. And that's because negative 2 times 3a squared gives me negative 6a squared, and negative 2 times negative 5 is a positive 10. So I get positive 10a and then positive 10 for my constant. And now I subtract these. So this becomes positive, this becomes negative, this becomes negative. And when I add these together, it actually ends up canceling out everything. And so in this case, I have no remainder, and that would just be my answer, a minus 2. But if you did have a remainder, like let's say, I don't know, you added them together and you ended up with like 3a plus 7 or something like that, this would still be your remainder because 3a is a smaller degree than 3a squared. And so you would write your remainder as this plus 3a plus 7 over 3a squared minus 5a minus 5, etc. In this case, though, that's not the case because we didn't have a remainder. But if you did have a remainder, that's how you would write it. Any questions on that? Okay. So the last thing you need to know to be able to do your homework, and this is actually only on one problem, is the factor theorem of algebra. So the factor theorem of algebra says that if you have a polynomial that depends on x, so for example, maybe like 5x squared plus 3x minus 7 or something like that. So if you have some polynomial that depends on x and you're dividing it by x minus some number. So maybe you're dividing this by x minus 5 or something like that. Then the remainder of the division is going to be that polynomial if you plugged in a 5. And the place where this is used the most is to see if there is a remainder, because if the remainder is 0, then that means the polynomials divide evenly. So that's where it's used the most. But this is kind of just a cool pattern that always shows up. And so on, I think it's question 14 on your homework. Yeah, question 14. This problem is all about verifying this theorem. So if you guys want to, you can open up your homework and go through this with me, because this was the main question on the homework I wanted to go over. Yes, this one. And I think on question 14, they actually restate it as well. Any of the questions that involve this theorem, they restate it on there. Okay, so on this one, essentially what they're asking you to do is do the long division for this and find the remainder. and then show that that really is equal to plugging it 3 into the original polynomial. So if I do the long division here, I have x squared plus 2x minus 17, and I'm dividing by x minus 3. Well, x squared divided by x is just x. Maybe I'll color code these still. So x squared divided by x is x. X times x minus 3 is x squared minus 3x. And when I subtract that, the x squared becomes negative and the 3x becomes positive. And I end up with 5x minus 17. And then when I divide 5x by x, I end up with a positive 5. 5 times x is 5x. 5 times negative 3 is negative 15. And when I subtract that, the 5x becomes negative, the 15 becomes positive, and I end up with negative 2 as my remainder. So if I was writing this as like an entire solution, I would write it as negative 2 over x minus 3. However, that wasn't what this question asked for. They just asked me for what the remainder is. And so in that case, the remainder is just negative 2. So that's the number I would put in that box. And the theorem tells me that because I divided by x minus 3, the remainder should be 3 plugged into this polynomial. And we could test that out and we could say, okay, well, if I do 3 squared plus 2 times 3 minus 17, what does that equal? Well, that's going to be 9 plus 6 minus 17. 9 plus 6 is 15. 15 minus 17 does indeed equal negative 2. So on this problem, you're basically just showing that theorem is correct. You find the remainder with long division, and you find what the theorem says should be the remainder by plugging in this number into this polynomial. And it's possible that you might have something where it's like being divided by x plus, maybe like 4 or something like that. In that case, you just need to think about what a would be, because the form is x minus a. And so if you have x plus 4, you can think about this as x minus negative 4. And that means you plug negative 4 in to get this step. But it should also say that in the problem. So you can also just plug in the thing that they said. Question 13 on your homework also has to do with this theorem. But they asked you to factor a polynomial, and we haven't talked about how to factor them yet. So if you know how to factor polynomials, you can do this problem. But if you look at your homework, it's like crossed off because I withdrew that question from the assignment, so you don't have to do it. But this is also related to the factor theorem. So yeah. Yeah, like this red part. Yeah, so what this factor theorem of algebra is saying is that if you have a polynomial, which we did, that's divided by x minus some number. So in this case, we were dividing by x minus 3. Then the remainder of that result, which we figured out was a negative 2 by like doing it the long way. The theorem says you technically don't have to go through all this work because this remainder will equal the 3 plugged into the polynomial you're dividing by. And so I plugged in 3 for x. So I got 3 squared, 2 times 3 minus 17. And I was just verifying that it really does equal negative 2. So on your homework, these two answers should match each other. So technically, you don't have to do the calculations for both to get the answer right. But the whole point of this question is to show that the remainder theorem really does work. All right, does anyone have any questions they'd like my help with? Okay, I'll let you guys just keep working. And if you run into any that you'd like help with, let me know.